Okay, I wanted to run through a quick little video on how you need to set up your graphing calculators so that you'll be able to get the polar equations to graph correctly. The polar system is not what we've been normally calculating in. So the graphing we've been doing has been on rectangular with the y equals, but we're going to be switching to r equals. So we need to switch our mode on our calculator. The first thing that I'm going to ask you to do is I'm going to ask you to go ahead and get your calculator out and follow along with this video with your graphing calculator right next to you. So run and get that and hit pause real quick. Okay, so the first thing we're going to do is clear our calculator so that we're all in the same mode. So you're going to do second plus 7, 1, 2, and that clears the RAM. And then just hit clear. And we are going to set up our mode, hit mode, and we're going to change our mode to degrees, because right now it's going to be easier for you to understand it in degrees with the 0 to 360 degrees. You could leave it in radians if you wanted to. Some problems will have it in radians, so you would want to switch back to the radian mode if that's what you want to look at. So we're going to be in degrees, and we also need to change to polar right here. So I'm going to go down and over, highlight the word degree, and hit enter, and then arrow down and over and highlight the word polar and enter. The rest of these things are all going to stay the same. Okay, to get out of the mode menu, you go to quit, which is second mode. And the next thing that we're going to do is we're going to go to window. And there's going to be times when you're going to be asked to change the step of your window, which is right now is the 0.13. That's the theta step. That's how many degrees it skips until it graphs the next point. So right now it's not in degrees at all. Right now 6.28 is representing 2 pi radians. So let's slide down and change the 6.28 to 360 degrees. Sometimes you'll actually ask for it to be more than 360, but most of the time it's just going to be that first revolution, so 0 to 360. Arrow down, and a step increase that would make sense would be 15 degrees, because that would give you the 30 degrees and the 45 and the 60 degrees. And then, it also gives you the 75 degrees, but then also the 90 degrees and the ones that we need. So 15 degrees would make sense. Leave the rest of these as negative 10 to 10, scales of 1. Okay, and let's go to the y equals screen. And you'll notice that it's no longer y equals, it's r equals. That's because all of our polar equations are in terms of r. So r equals, and then you would type in your polar equation here. For example, I'm just going to type in 4 plus 4 sine theta. Now theta is the x key that we're normally used to pushing. Except now that we're in polar form, it'll actually not kick out the x, it'll kick out the theta. Close your parentheses if you feel like it's not required for this, since that's the end of what I want to type. All right, let's graph it and see what we've got. Here's our polar. That's what I was expecting, but the reason I was expecting it was because the 4 and 4 were the same. You'll learn all those kinds of details. Now, our screen is scaled a little bit different on the x-axis than it is on the y-axis. You can see that the tick marks are tighter on the y-axis, and that's because your calculator is a rectangular screen instead of a square screen. So one feature that we like to use is the zoom, and we like to use zoom square, which is number 5. Zoom square, so I'm going to click on number 5. And there we have what's called a cardioid, which cardioid is rooted with the same word as cardiac, which is heart-shaped. So you should see that it looks like a heart. Some people say it looks like a peach. Some people say it looks like other parts of the body. But I like the idea that it looks like a heart. Okay, so that's how you would graph a polar equation on the graphing calculator. If you like to play around with it, you can go back to the y equals. You can mess around with the 4 and change it to something larger. Hit graph, see what happens. Well, doesn't look like much of a heart anymore. It looks more like a flat circle. We've run out of space on the top. Our y-axis is not tall enough. So we could go to window, change our y maximum to something larger, and then graph it. You can see that we captured it. And then again, zoom square to square everything out. And it gives you the same spacing on the tick marks when you do that. It does change your window value, so you're no longer at 10 and -10, but it doesn't matter. So again, you can change the 8 to another number. Let's change it to a 2, make it smaller. We can change the sign. See if I can change the sign. Oops, sorry. Change the sign to cosine and see if that makes any difference. Hit graph. Aha. And now our cardioid is no longer cardioid. This is called a limison with an inner loop. A limison with an inner loop. And that happens when the A value is smaller. Yep, A value is smaller than the B value, so 2 is smaller than 4. You'll also notice, excuse me, that because I typed cosine instead of sine, it's now oriented on the x-axis instead of on the y-axis. Excuse me. Okay, well, that's just a little introduction on how to use your calculator with these. You can refer back to this video anytime that you've just seemed to have forgotten and freaked out. All right, thanks. See ya.